And welcome to the Daily Space Weather. We've got a coronal hole high-speed stream about to show up. And we've got coronal mass ejections headed toward Earth. At least one very likely to strike Earth in the coming days. It's going to arrive sometime on the 14th. We'll tell you all about it here at the Smash News Network. Least busted name in news. This is the past 24 hours and 304 angstroms. And that CME that is headed toward Earth was from this CME that we saw yesterday. Again, we'll show you more detail on that later in the video in our coronal mass ejections section. First, some high-res imagery here of the closest star. We've also got some information about the solar cycle progression that you might find interesting. There's the northern hemisphere for the past 24 hours, and there are a massive number of plasma filaments. Sunspot number has now exceeded 200, and we've seen multiple M-class flaring events in the past 24 hours. There's a great zoom in on the equatorial view, and the likelihood of large solar flares remains very high, including M and indeed X-class events. Here's a little closer view of the southern hemisphere. And right at the beginning of the video, you'll see the tail end of that CME, just below our Earth scale there. And that one is headed toward planet Earth. Again, we expect that to arrive on the 14th of September. And let's just take a brief moment to remind you to press the like button. Thanks to our viewers for viewing yesterday. Thanks for the 4,000 plus views on yesterday's videos. So press that share button, subscribe, like, etc. Thanks again to our YouTube audience. Here is yesterday, September 11th, plus today to date, September 11th and September 12th so far. That's the SDO intensity gram. And things have been pretty stable here, although again, that is a lot of sunspots. There's your colorized magnetogram, and we're going to look at volcanoes and earthquakes here briefly. There have been some significant activities going on at the ground level, so let's take a brief moment to look at what's going on planet Earth. Kluchevskoy. Not sure if it's erupting volcanic ash, not identifiable in satellite imagery. Shiveluch, also not identifiable. It must be cloudy over Kamchatka. Subanosejima, however, is certainly erupting, producing an 8,000-foot plume of volcanic ash. Luatolo there, 7,000-foot ash plume as it explodes. Krakatau exploding, 7,000-foot ash plume at Krakatau. That's an uptick at the Sunda Strait, Indonesia. Semeru exploding, twice as high as the volcanic ash plume from Semeru over East Java, Indonesia. It's a 14,000-foot plume of volcanic ash, flight level 140. Dakono, flight level 080. As continuous volcanic ash comes out of Dakono as it explodes. Kilauea now continues to erupt here. However, the lava lake is largely crusting over there. There's the Halema Uma'u lava lake. And check it out, folks. A directed energy weapon is obviously what's turning on Kilauea. You see that beam there? That's totally not lens flare, folks. That's a laser from space, of course. Pardon my sarcasm. Indeed, there is some lava fountaining happening there in isolated portions of the Halema Uma'u lava lake. So that's what's going on Kilauea. It does continue to erupt, but it is largely crusting over. Popocatépetl in central Mexico exploding, flight level 220. It's a 22,000-foot ash plume. 21,000-foot ash plume over Colombia from Nevado del Ruiz. 20,000-foot ash plume over Sangay in Ecuador. Revenador exploding, flight level 150. And flight level 240 over Sabancaya in Peru. It's a 24,000-foot ash plume. Please do not pole vault the caldera. Please do visit the links and help support the channel. If you'd like to pick up some tangible products, try the Do Not Pole Vault the Caldera Red Bubble product. It's our top seller It features the homepage, smashomash.com, as well as the YouTube URL and the public service message. Don't pole vault the caldera. You could become part of the lithosphere, and that would be unhealthful. You wouldn't be able to view our fantastic daily space weather videos if you became part of the lithosphere. Our finest days lie ahead, so if you're going through hell, keep going. It has certainly been some tough times over the past couple of years. Wouldn't you tend to agree? And of course, we've got other affiliate/sponsor links as well. Another one of those would be the Hemp Lucid product. And the most popular product is the water-soluble CBD tinctures. So check those out. You can find links below the description to that as well. That is the full spectrum CBD water-soluble tincture. All organic. Quite popular there, the Hemp Lucid CBDs. If you haven't checked out CBDs, check them out. The whole list of products available there via the link below this very video. You can also find that link on our homepage at smashomash.com. And welcome to the Neo Renaissance. Big supporter of the mushroom stress gummies and the mushroom focus gummies. So check those out also. If you haven't, today's featured product on the Amazon storefront is L-lysine. Yeah, L-lysine. It's an essential amino acid, which means you can't make it in the body. You have to take it in through diet. And so L-lysine is responsible for the production of hormones, enzymes, and antibodies. Some people take it as a viral prevention agent, using it to prevent and shorten the duration of things like shingles. Yeah, shingles. If you are deficient in L-lysine, that is not a good thing. So perhaps supplement the L-lysine. There are certain dietary things that do contain L-lysine, but with the rather lousy diets of a lot of people in the Western world, it might be a good idea to supplement it. So amazon.com/shop/smashomash. You can find the products right there. And let's move to earthquakes. Yeah, it's earthquake time. And there was at least one 6+ magnitude quake in the past 24 hours. There, the past 90 days. And we'll call out quakes of a 5 or greater magnitude. So there was a 6.0 at Indonesia there. It was at depth. And there is the location of that one. That 6 magnitude quake occurred at 12:51 Universal Time yesterday afternoon. About 40 minutes later, there was a 5.4 across the Pacific there at Chile. That was a 5.4 at the surface, estimated depth 10 kilometers. Japan also had a 5.0 at 16:46 Universal Time. And then Russia. That is east of Kamchatka. There's a 5.3 out there in the ocean, it looks like. There is a location of that one. Again, east of the Kamchatka Peninsula. That 5.3 was at 22:51 Universal Time yesterday evening. And then check it out. Quite a few more 5 magnitude quakes here. Solomon Islands had a 5.1. That was at nearly 100 kilometers estimated depth there. That was at 1:18 Universal Time this morning. Loyalty Islands, about 20 minutes later, had a 5.0. At 2:40, Mexico had a 5.1. Then Chile had a 5.4. That's a couple hours later there, nearly over 3 hours later. And that is the last of the 5+ magnitude quakes. And let's head back to space, since there is plenty of action going on. Here's a 24-hour video from SDO 171 angstroms, the classic house favorite wavelength. Once again, sunspot number has soared over 200. And here's the equatorial view. We have had some plasma motions there. You'll be able to see some of those on the imagery. Mostly in the southern hemisphere. Despite most of the X-ray flux, and indeed large sunspots, located in the northern hemisphere. Next, the 10.7 centimeter radio flux. It's all the way up to 176 solar flux units. And here's a brief look at a 1-year graph of that. Again, the sunspot number is now way up here, above 200. Radio flux now at 176. So big solar increase, and if you're a regular viewer of the channel, it's not going to be surprising to you at all. And let's see what NOAA has to say on the Space Weather Enthusiast dashboard. So they're forecasting a little bit of geomagnetic unrest late in the day today and early in the day tomorrow. The coronal hole high-speed wind density portion has showed up a little bit earlier than expected, although it's looking pretty weak. So that might not create the geomagnetic unrest that we're seeing NOAA forecasting there. And let's talk about solar cycles. So first of all, here is the solar cycle progression. And let's zoom out here. So here we've changed the view from the strongest solar cycle of the modern age, which peaked around November 1957. And look at this cycle. You can see how steep the uptick is. Since the beginning of solar cycle 25, it is vastly exceeding solar cycle 24. In fact, it might even find itself a stronger cycle than solar cycle 23. Again, the sunspot number is currently way up here at 200. And there's a long way to go to solar maximum. The forecast for solar maximum is not until about 2 more years. So you can expect at least 1 more year of increasing activity. And let's do another comparison here. Now, keep in mind this was not updated since September 1st. And this is the daily sunspot number here, this black line, which would now be up here off the chart. So that is how much stronger of a solar cycle 25 is versus 24. And if you are still thinking that for some reason that it is a grand solar minimum, you are in a cult. You are believing nonsense. You have a living leader, and this is harmful because you are in denial of reality. I mean, look at the chart, folks. There it is. A much stronger solar cycle than cycle 24, and it looks nothing like it. So, I mean, this is just one of the many pieces of data debunking this ridiculous claim. You need to have at least 2 very weak solar cycles in succession for a grand solar minimum. You don't have that. If your hypothesis required a grand solar minimum in order for it to be correct, abandon that hypothesis. It's clearly incorrect. If you've invested in the bank of the grand solar minimum, take your money out now while there's still anything left, because it was a terrible, terrible investment. Next, Earth's magnetic moment from space for the past 4 hours, and it is still geomagnetically calm at the moment. Again, we aren't expecting a super powerful coronal hole high-speed stream, but it could create geomagnetic unrest. So at the moment, we haven't seen the high-speed portion of it show up. Only the density wave, which we'll show you here momentarily, and the density wave has not been super extreme. Next, the past 4 hours of Earth magnetic moment from the ground. It's our ground magnetic perturbations map. This will show you the most likely places to see the aurora. Also to see pipeline, railway, and power grid induction due to incoming space weather. Again, it is quite geomagnetically calm here at the moment. We could see a significant uptick coming today. So there's the KP index only at 1.33. KP 1.33 is the current situation. Calm is the situation. So all right, so now we're seeing a little increase here. It looks like it might be a CME impact, actually. Or perhaps just another high density wave there from the coronal hole high-speed stream. So density only made it up to about 12 protons per cubic centimeter. That is not very high at all. However, now it has increased again, so looking a little stronger density wave there, folks. So that's promising. Also, the field increased a little bit there. So most current conditions are about 17 protons per cubic centimeter. Solar wind speed here is still slow, 358 kilometers per second. If we do see a strong coronal hole high-speed stream, we'll see a big increase in the solar wind speed, preceded by a dip in the solar wind density. Total field is 9 nanotesla, BZ is 0. Moving right along to our GOES magnetometers, you can expect to see these get some sawtooth readings when that coronal hole high-speed stream portion does arrive. At the moment, quite smooth over the past several days here. It has been very calm space weather for a solid week. Next, the top view ecliptic plane field plot. There is a sector boundary crossing coming in about, I'd say, probably something like 36 to 48 hours. There's the last image. Oh, geez, look at that. There's an indication that we might see some more sunspot growth in the northern hemisphere. So look at that. Let's play that through again. Sector boundary crossing is getting moved way back there. Whoops. So, okay. There's a prime example of how the magnetic environment can change with basically no warning. So sector boundary crossing now is several days back. Now keep in mind that can change again. That is an indication that we may see some additional sunspots about to rise in the northeast. Or perhaps some major growth in the existing northeastern sunspots. Here's our line of sight field plot. And this gong imagery, folks, is some of the most important imagery that you'll find. It might not look as cool as the SDO imagery, but those potential field surface lines are super important. Anyway, Earth is going to be in a South Pole current sheet for the foreseeable future, and let's move on to our coronal hole line of sight field plot. There's our coronal hole line of sight plot, and we've got mostly South Pole oriented coronal holes here, with some North Pole coronal holes showing up in the southeast and in the northwest. Here are those from SDO. So 211 angstroms is a great wavelength to view coronal holes. Once again, these are south, these are north. That's pretty much what's going on. That is another 24-hour video. And let's take a little closer look. And by the way, expect an increase in coronal holes in the coming 2 years. It's basically just another statistical analysis, folks. Why do I think there's going to be an increase in coronal holes? Because we've had a shortage of coronal holes throughout solar cycle 25. So there's a little closer view. You can expect to see larger coronal holes and more trans-equatorial coronal holes over certainly the next year, more likely the next 2 to even 3 years. So there's still a lot of activity left for solar cycle 25, and let me just reiterate, we are nowhere near solar maximum. Solar maximum is a long way off. We are even expecting a further increase in cosmic ray flux. Why? For the same reason, because cosmic ray flux is inversely proportional to the sunspot number. Anyway, here's our flare probability monitor, and check out the likelihood of large solar flares there. We've got many magnetically complex sunspot groups. So if we stop that, check it out. Number 2 there, that's this sunspot 3423. Nearly a 50% chance of an M-class flare and a 42% chance of an X-class flare there. So multiple sunspots here, quite magnetically complex, And actually, we are seeing some activity happening in the northeast. So up here, there is some activity happening, which we'll show you some more up-to-date imagery on in a minute. Here are sunspots for the past 24 hours from SDO Continuum. So magnetically complex, large sunspot groups all over the Earth-facing portion of the solar disk. If you were worried the sun is shutting down, maybe that gives you some confidence that the sun is not shutting down. I mean, what more can I say? Hi, it's 200 plus sunspots. We'll also show SDO magnetogram. And not a lot of evolution happening in those groups. They haven't been evaporating, and they haven't been growing. But they are certainly there, and there are certainly a large number of umbrae right now facing the Earth. Also still a huge number of filaments, which we're going to cover here. So let's blast through some more data. Here's the past 24 hours in ionized carbon. And this is sort of a preface to our flaring section. You might see a lot of white showing up there at the time of solar flares. It's carbon being produced right there on the surface of the sun in plain sight. Yeah, metals. We call everything more massive than helium a metal when it comes to cosmology. And so carbon, it's heavier than helium, therefore it's metal. That is 1,600 angstroms from SDO for the past 24 hours. Next, we'll look for energetic particles in solar flares. What do we got? No spikes in the proton flux despite multiple M-class solar flares in the past 24 hours. Proton flux flatlined. And we've got, let's see, we've got 3 M-class solar flares here. The largest one was the most recent one, an M2.4. And let's cut back to SDO. There's 94 angstroms. And it looks like that most recent one was out of this sunspot group right here. Yes, indeed. So again, we've got multiple groups that are capable of producing large flares. We've got at least one coronal mass ejection headed toward Earth, a coronal hole high-speed stream showing up, and a couple of years of activity at least at this level, if not at higher levels. And let's step back and see what's going on overhead. So here is our star chart. We show it daily on the channel. There is the current situation over Lehigh Valley, Pennsylvania. We've got a sliver of a moon up there. We've got Jupiter. Also Venus rising ahead of the sun. If you've got a view of the morning sky there, the pre-dawn sky, you might see Venus and a sliver moon up there. The second and third brightest objects visible from planet Earth. Next, it's Abel 317, the astronomy photo of the day. And I guess this might trigger some people. This is going to trigger people to say, Einstein was wrong, even though there's all this lensing. So you see those streaks, those real distorted-looking galaxies there? Those are background galaxies that are nearly twice the distance from Abel 317, which is a galactic cluster consisting mainly of these 2 large elliptical galaxies. So those foreground galaxies are somehow warping the imagery of those background galaxies. That's why they look so distorted. How do we know it's the background galaxies? Because the spectra. If you examine the spectra of one galaxy, and then you can find another image that shows the same spectra, in other words, the color and intensity are the matching color and intensity, it's an indication that you're viewing the same galaxy in a distorted fashion. It's called lensing. as the light has to pass through this huge galaxy to get to you. And that's what is causing the distorted imagery. Sometimes referred to as gravitational lensing. Again, that will trigger some people. And let me just reiterate. I've had to say it a few times. Electric universe is not science. It is pseudoscience. And if that triggers you, I'm terribly sorry, but those are facts. And that is lensing. And no, Einstein wasn't wrong. Might there be more to it than Einstein? Sure, there might be more to it than Einstein. However, Einstein was not wrong. And that bright blue star, that's a foreground Milky Way galaxy star. Again, Abel 317 is this galactic cluster right here, and these distorted galaxies are like twice the distance from Abel 317. apod.nasa.gov if you want to check that out yourself. apod.nasa.gov. And let's do a solar system forecast next. Shall we? Yes, we shall. Here's where things are today. That's where things will be in a week on the 19th. And let's get to CMEs. So around midday yesterday, we saw a CME known as a coronal mass ejection. That's when the sun blasts material off from its atmosphere into the greater solar system. And one of those CMEs, at least, is headed toward Earth. You might see a bit of a halo there. About halfway through here, right in there. So that halo eruption, that is a CME that is likely to strike Earth. In fact, it's almost 100% chance to strike Earth on the 14th. So CME impact there for the 14th. That's 100 frames from yesterday. And there was another CME that we'll have to analyze here that showed up later in the day. So right there's a second one. Here's sort of the aftermath of it. We've had multiple events here. And one of them we've already analyzed sufficiently. That's 38 frames from today. Let's actually skip ahead here. Here's Soho Lasco C2 and C3. And if you bring those back, there is yesterday's around noontime universal time. There's a halo eruption right there. Earthly directed CME, in other words. And then later in the day around 2000, you see a second one. That's the one that we'll have to look at. Around 2000 universal time there, another halo CME happening. So let's blow that up a little bit. Again, here's the one happening around noontime. So there's one earthly directed CME. Again, that'll be likely to arrive on the 14th. Sometime late in the day on the 14th. So sometime in the evening, universal time on the 14th is when that one will arrive at Earth. Could be as much as a KP 6 or 7 from that. So it could cause a significant geomagnetic storm. We could see aurora at mid-latitudes as a result of that. The next one, happening around 2000, is the one I'm not sure about. So there it is. It starts out around 2000. So there's 2312 on the C2. So it does certainly look like another halo eruption there. And let's consult NASA's Enlil spiral. Doesn't look like it's modeled yet. So let's move on to check out our Twitch feed from yesterday. So just before 2000 universal time, we're going to move this ahead. As we want to see if that is an earthly directed CME or if it's on the far side of the sun. To move this a little bit further ahead here. So based on what I see there, I'd have to conclude that that other one is on the far side. So once again, here's a recap of the CME situation. Yesterday around noontime, a CME popped off from the southern hemisphere. That is earthly directed, almost directly headed toward Earth. We can expect that to arrive late in the day on September 14th. Sometime well after noontime, probably in the evening on September 14th. This other one, starting out around 2000 Universal Time, looks like it is on the far side. We don't see any plasma motions on the Earth side from that one, so there's no other deduction to conclude except that one is on the far side. Just think, folks, in a couple months we're going to be able to see this in a lot better detail from stereo A, which at the moment is not being very helpful because it's so far in line with Earth. So there you can see the where is stereo A today image. That red circle there, stereo A, still very much in line with the Earth. And there is the CME from around noontime yesterday. So that is certainly earthly directed. Could see as high as a KP7. I would say probably more like a KP 6.33 from that. There is a bit of a dense core there. That looks like it will miss Earth to the east. You can see that right there. That is certainly the densest portion of it. So CME impact coming on the 14th. Exciting stuff when it comes to space weather. And let's take a look at filaments here, as we'll be able to see the filament that ejected, I suspect. Let's slow that down a little bit. So great view here from El Teide, Spain. A massive number of filaments continue to dominate the Earth-facing portion of the solar disk. The Eugene Bagashov filament here, the Selena Gomez filament up here. I named that one after Selena Gomez because of one of our viewers. And if you want to name filaments after living people, join us over on Twitter. Still got several filaments that could get names. Let's just slowly advance this here. Yeah, so that Earth-directed CME, that was actually part of a crown prominence. That was happening as we made yesterday's daily space weather video from down here in the southern hemisphere. Good stuff. And once again, thanks to our new Twitter followers. If you want to see additional content over there on Twitter, then follow us over on Twitter. If you want to name solar filaments after living folks, follow the hashtag #NameThatFilament over on Twitter. I'm not calling it X. That's not a brand. X is not a brand, folks. X is a letter. Don't name your company after a letter. That's not a brand. I don't know how else to say it. You can't trademark a letter. You see, because people need to use letters for work. Never mind. Anyway, there's the grayscale imagery. And again, a lot of solar filaments. There's a huge amount of material pointed directly toward Earth. So also there is some activity happening up there in the northeastern limb, as you can see. It looks like that one might be all splashing back down. So a great example of how sometimes you have a huge prominence that does not become a CME. I suspect some of that material probably did eject. That is unlikely to be earthly directed. And let's move on to our bonus features. First bonus feature is the satellite community dashboard. We don't have any charging hazards for satellites here at the moment. It's smooth sailing. We don't have surface electrons building up on the outside of... We don't have low energy electrons building up on the surface of satellites. We don't have high energy electrons building up in the internal circuitry. The GOES electron flux is kind of low, and you can expect it to remain low here, again, because there is a coronal hole high-speed stream about to show up at any moment. So expect that to remain cratered. There's the one-year graph of the electron flux from Solon.info. And NOAA largely agrees here with, well, they're showing a little uptick in the electron flux. I don't know. It's going to be lower than that forecast. I would suspect That's the NOAA forecast for the electron flux. We'll also show the layer where that is measured. So keep in mind, folks, the GOES 16 and GOES 18, they're way above this. They're at like 23,000 miles of altitude. The F layer is at 300 kilometers of altitude. They are using radiography to measure the electron flux at the F layer. So here is the vibrational frequency of that layer. The bridge between Earth and space. So we are seeing a little bit less amount of high-frequency anomaly on this map. Well, still quite a bit of high-frequency anomaly there. Anyway, if that's Greek to you, don't worry. We'll show you the anomalygram. That should clear things up. And here it is. That's anomaly in megahertz from the 30-day median. Still quite a lot of blue on the map there. Low-frequency anomalies shown in red, and you can expect those to increase if we see a strong coronal hole high-speed stream. At the moment, things are still very calm in the Earth system. Anyway, here's the latest image. That's 11:15 universal time for the ionogram, and there's 11:15 universal time ionogram. We'll also show total electron content. Feel free to pause the video on this frame if you're not familiar with distances to things like your GPS satellite. It's at about 12,500 miles of altitude, and there is the electron count. It's literally a count of electrons, folks. It is a two-dimensional map depicting electrons from ground level to about 12,500 miles of altitude. Your GPS satellite is only about half of the altitude of the GOES satellites. We'll also show the North American total electron content, at least the anomaly from the 10-day average. So nothing too exciting going on there. We are still seeing a little bit of high electron content anomalies there over portions of Canada. But for the most part, things are pretty chill. Next, the latest intensitygram and latest colorized magnetogram as we close out our space weather section. What's going on up here? It's an alpha class sunspot, folks. It's only got one polarity umbra there. North Pole, as you would expect. There it is. A large sunspot that is alpha class. So a great example of a sunspot that is not super likely to produce large flares. I suspect there may be another active region behind there, as we are seeing activity without magnetic complexity. Of course, these two groups here are the most magnetically complex sunspot groups. That is a beta gamma delta class sunspot, the most likely classification to produce large flares. This one over here is also beta gamma delta class. And we have been seeing significant flaring all over the solar disk, really. I mean, this one down here is also beta gamma delta class. And that one up there is beta gamma delta class. That one there is, guess what? Beta gamma delta class. So, yeah, a couple hundred sunspots. The sun not shutting down, but we are shutting down our space weather section of the video. And to help us prevent ourselves from shutting down the channel entirely, please visit our links. And welcome to the Neo Renaissance. We launched our homepage back in February of 2019. So go visit them. You can find the Redbubble shop, the Hemp Lucid shop, the Amazon shop, the Spotify music page, a permanent invite link to the Discord channel, and more over there at smashomash.com. If you want to support the channel via subscription services, become a member of the Smash Team, smashomash.com/Smash Team. You'll get additional content. You can even get an @smashomash.com email address if you'd like. Most first names still not taken. If you want, like Steve or Pierre @smashomash.com, we've got that. And now we've got meteorology, a value-added service. So check it out. We're looking at the sea surface temperature, not the sea surface temperature anomaly, although that anomalously cool water is good for the people of Nova Scotia. We'll tell you why here in a minute. We're looking at winds. That's the animation. And of course, that Atlantic hurricane has been weakening as we've been forecasting due to things like wind shear, and that's only going to continue to weaken. However, there is still heavy rain coming. So don't be confused by that. The winds are going to subside, but the rain is going to happen. So be prepared, Nova Scotia. It's very likely that you will be hit by this, at least the remnant. It's not going to be a hurricane when it gets there. Why? Because up here, the water temperature is only 67.8 degrees. However, down here, it's over 80 degrees. So there still is significant convective potential. However, there is also wind shear in between Nova Scotia. There's wind shear. And that does not help hurricanes to stay organized. So that's a brief explanation. We're going to show some actual forecasts here, some models. First, let's go around planet Earth and check out the surface winds and jet streams. Surface winds of the east looking like this. Jet streams of the east looking like this. Jet streams of the central world looking like this. Shout out to Sepp Kuss. We hope you win the Vuelta a España. Here are the surface winds of the central world. In the last week of the Vuelta today, the third 3-week stage race of the year could be won by an American from Durango, Colorado, Sepp Kuss. One of the best names in the pro peloton. Sepp Kuss. Shout out to Sepp Kuss. Currently wearing the general classification leader's jersey. Anyway, surface winds of the western world looking like this. And let's don't forget the jet streams. Again, you can see the jet stream is already kind of hitting this with some dry mass of air. And that is a good thing for those of you who don't want disasters. For those of you who do want disasters, sorry. That's not going to be helpful. And let's take a look at some forecasts. So we're just going to show the GFS and the Euro forecast. We'll show the Icon forecast also. So here's the current situation. We're going to show 3 days in advance. So we're going to move this ahead to Friday at Friday at 12 noon Universal Time. It'll be directly off the coast of Ocracoke there. So right off the coast of North Carolina is where that'll be Friday at noon. That is noon Eastern Time. 1600 Universal Time. That's the Euro forecast. The GFS forecast putting it farther north. And that will be affecting the East Coast, by the way. And the Icon forecast, more like the Euro forecast. The Euro forecast has it the farthest to the west. Icon has it farther east. And GFS has it farther north. As far as the winds go, I don't think these are hurricane force winds. Well, still looking like it's a hurricane there. If windy's showing 69 miles an hour, I suspect that is still hurricane force. So, but those are the forecasts. And if we bring this back to around now, it's going to continue to turn almost due north. In fact, it's even going to be going a little bit east, it looks like, according to the GFS model. Again, Euro model will have it farther south. Icon model will have it farther to the east. So here's what's going on. It's a satellite imagery for you. Let's take a closer look at Hurricane Lee. So not super well organized. You can see a lot of disruption happening there in the northwestern edge of that. That is a result of dry mass of air that we talked about yesterday. There you can see that dry mass of air. And fortunately, there is cool water in between Nova Scotia and that hurricane. So you can see much less organized than it was a couple of days ago on our water vapor map. Let's take a look at some more forecasts here. Frost advisory there for parts of Wisconsin and Minnesota. There is the key. Weather.gov is where to get your weather alerts from the National Weather Service homepage, weather.gov, and here come some forecasts By the way, these are from Tropical Tidbits. The forecasts that we regularly show on the channel are tropicaltidbits.com. Make sure you check out their website, tropicaltidbits.com. Here's a 72-hour GFS pressure and precipitation forecast. And you can see that system breaking up there. So that's not going to stop a massive amount of rain from coming. However, the wind is going to subside. So the pressure will continue to rise there as it moves north. But again, there will still be a massive amount of moisture. 72-hour GFS pressure and precipitation forecast will also show the total accumulated precipitation forecast in inches. Several feet of rain there falling in the Atlantic Ocean in the next 3 days. Also heavy rains coming to the northeastern U.S. Portions of Texas, Arizona, New Mexico, and Colorado, and don't forget Oklahoma. Some very heavy rains there coming to Oklahoma in centralized regions. Next, the wind forecast. (72-hour), that is mean sea level pressure and 10-meter wind. And it does not look like it will continue to be hurricane force there for too long. Last but not least, let's show the jet stream. It's actually in control of the weather. 72-hour, 250 millibar wind forecast. And so we're going to have some multiple pulses here. You'll have this jet stream pulse and then another jet stream pulse coming from over here. That will serve to weaken the system, further breaking apart the upper level portion of it with that wind shear that we talked about. So, facts. Next, lightning. Here's the past 10 hours. Texas and Florida have been the lightning capitals. And let's check out a real-time lightning map. Do we have any terrestrial strikes? I'll bet we do. And there you go. So southern Texas there. Southwestern Texas? I don't know what you call it. It's a big state. There are some terrestrial strikes right there. It is not an extreme storm. Looks pretty mild. There's your full map from lightningmaps.org. Highly recommended. And we'll close out with Doppler radar, clouds and fog, and water vapor. So there's a full 50-state view. We're going to focus on the lower 48 view. We've got rain stretching all the way from Dallas to Toronto and beyond. A very large band of rain there. About 1,500 miles in length. Here is shortwave radiation depicting clouds and fog. And let's don't forget water vapor. So again, multiple waves of dry mass of air there. Those will both help to weaken that hurricane. And no, it is not being created or controlled by mankind. Anyway, here's your recap. Vertical motion of the air column by ground-based Doppler radar systems. Space-based satellite infrared radiation showing clouds and fog. And a different band of infrared radiation showing the water vapor. Again, all that orange on the map there is a good thing for those of you who don't want to see utter destruction, and a bad thing for those of you who want to see destruction because you think it's going to boost your YouTube views. Anyway, sorry we can't forecast any doomsday. Sorry, the apocalypse has been canceled, folks. Anyway, we'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.